Cuarto día del Mobile World Congress 2014, estamos iniciando una nueva sesión de paneles de vídeo con entrevistas con varios ejecutivos del sector. En este caso estamos tratando el tema de signaling. Vamos a cambiar al inglés para recibir a Kim de la empresa Ulticom y a James de la empresa Dialogic, y con ellos vamos a estar hablando de temas de signaling. James, Kim, thank you so much for being here.
Thank you.
As I said to you and our audience, we're going to be discussing signaling. And although you guys are more on the network side, I'm going to have to take you back or take you out of the network to the devices. So you can tell me exactly if one of the situations that was highly reported on the press, which is how smartphones are impacting the signaling network because of different mechanisms that they might have, and you can probably explain those, we're having a very bad impact on NTT Docomo's network or on AT&T's network. Has that been solved? Devices impact on the network? James, you want to start?
Has it been solved? I'd say no.
Okay. Bad news.
But you know, we're in a different world these days. The telecom arena has primarily been, you know, a very closed system for a very long time. And they're going through this process from being a very closed system, you know, SS7 and you know, other signaling protocols that you couldn't really get into from let's say the internet. With the internet and telecommunications kind of converging for this new world of communications, it's going to cause all kinds of problems. And the fact is that the way that the internet does things and the way that the old telecom do things are different. And we're moving more and more towards the internet way of doing communications. And with that, it's going to cause some problems. As you mentioned before, you know, overloading networks with requests and et cetera. The communications from the old telecoms has been very much geared about, we know how much traffic we're going to have, we know when it's going to spike, we're going to control all that. And with the internet way of doing things, that control is very different. And so they're going to have issues. Much like when we moved into SIP, you know, being a voice over IP protocol, it caused issues because you could get spikes and you could get applications that did things that weren't really known before or weren't really done before. And so, for example, on SIP registrations, what we found is that you really needed to place an SBC, Session Border Controller, to protect your network from those spikes in registrations. If a device moves and it needs a registration every 50 seconds, the SIP application servers back in the core network couldn't handle that. And so SBCs were put on the edge of the network to take care of those quick registrations, and then the core just got registrations every once in a while or updates. Okay. I think with diameter, we're going to need those same types of things where an edge element is going to protect the core DRA from the attacks and from the massive influx of registrations that are coming from those devices. And the fact is that the devices are just going to get bigger and bigger and bigger, meaning more and more. Many more billions of devices. I mean, our watches are going to be now devices. So,
Kim, do you agree with that?
Let me offer a different perspective, because I think actually at least the outages that you referred to, the NTT Docomo and the outage we had on the East Coast in the United States, to some extent was caused by poor network infrastructure.
Okay.
And I think by applying what we know as a diameter signaling controller with the appropriate congestion mechanism, those outages would not happen. Okay. Because the outage was actually caused by trying to save batteries on these devices, so they did detach, attach all the time. Okay. That flooded the network, and it wasn't dimensioned for it, and the congestion handling was not in place. It is a very new network, right? So more resiliency, more robustness in the network will take care of that kind of problems.
Would that situation James mentioned between putting those machines to handle those requests help with that? Is that something that it's standard in the industry? That, you know, do you agree with that kind of solution for the network, or how do you make sure? Let me put it differently. How do you assure that devices do not impact the network by having a good network architecture, as you were saying, probably it wasn't well dimensioned?
Yeah, this is not a new thing, right? We had the same problems 20 years ago on SS7. So it's about how you do your network architecture. Okay. And when you have border elements, James mentioned the SBCs,
the SBCs.
For the calls, right? but also for the diameter signaling, you need at the border to make sure that it is safe and secure and robust.
Okay.
So you need also the proper congestion handling. And we were used to in the old days that we had limited bandwidth because it was TDM based. That's not the case anymore. So you have to make sure that you can handle traffic spikes that are much, much higher than what you were originally architected at.
So if a Latin American operator is watching this video and says and remembers the NTT Docomo cases or the AT&T cases where devices were damaging the network, could they be confident that there are solutions out there that would remove that factor from the equation of having their signal network down because of a poor device implementation of applications and battery savings and all these things?
The network has to be robust to devices, right? I don't think there's any way that we can control devices.
Okay.
So the network has to be able to handle any kind of device, size or malfunctioning or even malicious, right? So, yeah.
I agree. The network needs to be, very secure. It needs to always be up. I mean, we've come to expect communications to work. However, how many times does the cell phone call drop? I mean, they're not there yet, right?
Yeah.
Now, my background before I came to Dialogic is I built over-the-top applications.
Okay.
So I'm very familiar with the problem with battery drain with cell phones. And we built a SIP client, and Android does it one way, Apple iOS does another way. The fact is that you need to connect and disconnect, unless they fix a lot of things. But the fact is that we've got a lot of people that are building things that are, we'll call it non-standard.
Okay.
And I think we need to get out of this mode of thinking that everything is going to fall into this little box of this is the way that we've always done it.
Yeah.
Because if we do that, then this industry is going to have problems with the WhatsApp and other things because they're not playing by the same rules. And so I think that the traditional carriers are starting to realize that they need to do things a little bit different. Yes, it needs to be secure. Yes, it needs to be managed, but we also need to play a little bit more in the internet arena that says, if it fails, what do I do? The internet has this philosophy of let it fail, not because if it fails, so what? Yeah. But if that fails, we know how to take care of it because we've got multiple things.
Okay.
The telecom arena is originally
we can
1+1.
Yeah.
1+1 is, so if your primary goes down, you do secondary. The internet is an N+B, where you've got all these active ones, and if one goes down, so what? And I think that the edge agent, diameter edge agent, needs to have that type of a philosophy that we can handle those requests, but you know what, if this one goes down, there's another one that's available, and we're going to protect the core network, the DRA, but our edge is going to be able to not only protect the core, but also be able to interwork between the different types of protocols that are out there and the diameter in the core.
Okay. Now that you bring that, the internet world within the telco domain, we need to talk about SDN and NFV because it seems that that's what the internet world has been using on the data centers and so on to manage their own infrastructure.
Right.
Are we seeing any SDN, NFV, especially NFV, on the signaling infrastructure? And if so, how that would work? Because for what you're saying, we need to put some hardware at the edge of the network.
It's clearly a trend. We are right now in a major rollout with a tier 1 operator in Europe, all virtualized.
All the signaling virtualized.
So the diameter signaling is all virtualized, right? It's not like we go like in the old days, the rack-mounted servers or the blades. No, the operator provides the hardware infrastructure. Mm-hmm. We provide the application, and it's very interesting. Where we in the old days, right, we had to dimension our hardware for the worst scenario, and it has to be able to fail, right? So it was layer by layer of capacity.
Yeah.
Now we have to talk to the operator and say, okay, how does it scale? I manage the CPUs, I manage the memory, I manage the disk. You tell me how traffic and use cases influence the hardware resources, and I turn that on myself. So it's a completely different paradigm. But it's clearly, and I know several operators that has this as a core strategy, that network functions has to be virtualized.
Okay. Absolutely, I agree.
Completely?
completely.
I talked to I mentioned to Kim that I was spoken to the CTO of Telefonica, the global CTO.
Yep.
And he said one of the first things we're going to virtualize is signaling.
It's true with most of the carriers that we talk to as well.
So
the fact is today, in almost everything you build, some people still want the old iron, so you've got to have that. But even the big iron stuff is somewhat software. The question is can you get away from the hardware? Can you deal with the SDNs? NFV is not just about putting software on a virtual machine, but another big part about that is can it grow and shrink? Is there this orchestration capability so that as the demand comes on, you can grow and you can shrink when it goes away?
Okay, now that we talk about NFV, in terms of running the network or putting infrastructure in the network, how that is going to save money? What are the savings, and why is signaling the first step? Is because it's cheaper than doing it anywhere else? It's easier? Why is signaling so important, for example, for the CTO of Telefonica, and that said this is the first step we're going to do with NFV? Why signaling? It's easier, it's cheaper, it's where you get more benefits?
Well, I think if you take a look at it, I'm sure media is going to be the same way.
Okay.
But of course, media is very intensive, right? We're talking very, very large amounts. So it is also a little more difficult and challenging. The signaling is a little more robust to latency. You can handle it better than you can if you have media streams. Well, you have to provide, you have to deliver, right? There's a real-time component to this. Signaling, you have a little more latency looseness.
Okay.
So, you say it's about saving cost, and of course it is all about capex and opex, right?
Yes.
And maybe actually even predominantly opex, because of course you still have the capex, you still have the investment in the hardware infrastructure, but the operational side of it is so much easier and so much faster. So when you deploy services like we're doing at the signaling controller in a virtualized environment, it is so much easier because everything is prepared from the service provider, and they download the application, install it, and since they own the whole infrastructure, it is a very easy, very smooth installation, obviously.
A big part of the saving cost is when you buy a big iron piece of equipment. Okay. It's purpose-built,
so
it's
hardware.
just that. It can't be used for something else.
Okay.
With NFVs, you can use the same piece of hardware today for application A and tomorrow for application B. The other thing is that as your applications scale, you don't necessarily need to go and buy new hardware. It becomes available. It's
very true, right? And we can see that because every operator likes to start small and grow big, right?
Yep.
It's always been a problem with the iron, right? Because you don't want to change the iron all the time.
Right.
But with NFV virtualization, they truly start small and they just turn it up over time.
That same rack space, you don't have to pull equipment out and put new equipment in.
You use the same thing.
For bringing up systems and solutions, for trying out things. I mean, as a developer, if I want to go and build something in the old way of doing it, I would have to work with my IT group to acquire a PC because all the other ones were used, finally get it in, rack it, stack it, put the IP address in, load up an operating system, and then I could do it. It may be a month. Now I can push a button on Amazon, I can have a machine up and running in a couple of minutes. That's huge savings.
Going.
That's huge savings.
Yeah.
And when you have deployed your service, everything is set up, and now the hardware has to be replaced or whatever, you move the virtual machine. Everything stays the same.
Okay.
So from an operational perspective, there's not all the IT technicians that has to run around with cables, right?
Well, Telefonica mentioned at some point when I was discussing this with them, they were mentioning the staff, and they were saying, it's our most expensive thing is not machines or network, it's staff.
Yeah.
So it sounded like at some point, and this is going to sound really bad, but at the end of the day, NFV and SDN, what's going to get is a lot of people fired and then new people with less skills on board of the operator, few people managing, I don't know if this is something that, could be worrisome for some people at the operators, or I think the way life works?
I think part of what you're going to see is that innovation can flourish again because things will become available again. Okay. And it's not just that I can build a machine, but one of the great things about the cost savings too is if I build a machine on Amazon and it works but I'm not going to use it for, I go away on vacation for a week. I can shut down that machine. I don't pay for it. And it's not using CPU. I still got some disk space there. I pay a little bit for disk space, but then I bring it up, it may go somewhere else. It may start up on a different rack on a different PC, but to me it's exactly the same thing. So developers now can develop really cool things, and that's what these carriers want. They want new, cool applications that people are going to come and use their infrastructure for. And by having these types of cloud-based application or cloud-based solutions, developers can now do cool things that they've never been able to do. It's how WhatsApp has been able to be, great. It's they over the top love this model, and even some of the older brick and mortar are really going into the cloud. With the cloud, there's both the private cloud and the public cloud. And I think the carriers they're going to start using the private cloud internally as well. I think that'll be a cost savings internally.
In terms of the staff, do people at the operators need to find a new job and the signaling, the ones that are handling signaling because of NFV?
I think the operators need to, follow a little what James is saying. Operators need to make money. And in the new world, they have to be a little faster reacting, a little more creative. The old days where you get 70% of your revenue on voice, 25 on text, and then a little here and there, right?
Yeah.
It's not going to fly.
Okay, excellent. Well, Kim, James, thank you so much for being here. Last day of the show, so you will be able to rest very soon. Have a good remaining of the show. It's almost done, so thank you so much for being here today.
It's a pleasure. Thanks for having me.
Thanks.